In this how-to video, we'll take a look at Monte Carlo analysis in PSpice. Monte Carlo analysis allows the performance of a circuit to be evaluated when component values within the circuit are varied randomly within the bounds of their tolerance. In this case, we'll be using a simple common emitter amplifier, and performance of the circuit against the tolerance of the resistor values will be evaluated. In recent releases, the PSpice resistor symbols have a tolerance property which can be used directly in the Monte Carlo analysis. So we're going to select all of the resistors using the control and left mouse button, and then we'll do a right mouse button, edit properties. Here's the tolerance property, so we can select the tolerance property, do a right mouse button and edit, and we can then edit all of the tolerances in one go. So we're going to specify this as 1%, and then we'll apply that and then close the property editor down. Once that's done, we're now going to edit the simulation profile. So we're going to specify a time domain transient. The runtime we're going to specify as 1M. We're then going to go and enable the Monte Carlo worst case analysis. The output variable is going to be specified as vcol. The number of runs we're going to specify 100. We're going to use the distribution, a Gaussian distribution, and we're going to specify 17366 as the random seed number. We could use any number, effectively between 1 and 32767. Once that's done, we'll OK the simulation settings, and then when they add a voltage probe onto the ColNet. Once that's done, we'll then run the simulation. The probe window then comes up, and we effectively get all the 100 sets of results in the window, which we're just going to accept. From the voltage marker on the ColNet, the output range is about plus or minus 200 millivolts, but it would be better if there was some more statistical view of this data. So we're going to use the performance analysis mode from the trace performance analysis. We'll just click OK, and then we'll add a trace to this plot using the trace add trace. The measurement function is going to be max, and the net we're looking for is vcol, and this then generates the trace expression max vcol. In the bottom, we'll click OK. The percentage of the samples against the max vcol is displayed, but obviously it's quite squashed. So what we'll do is we'll select this probe here, and we'll do plot, delete plot. The results are then of the statistical analysis values can now be seen. This concludes the Monte Carlo analysis how-to video.